Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider and you're watching Learn and Teach by Sir Ayaz. In this video lesson, I'm going to talk about the topic stoichiometry for P2 5070 or P4 0620. It's a kind of chemistry worksheet covering the topic stoichiometry, and I have randomly selected some questions from summer 2023. So I'm going to explain it. So is question number 1. Zinc chloride is a soluble salt. It is prepared by the reaction of an insoluble base with a dilute acid. The equation for this reaction is shown. ZnOS plus 2HCl AQ gives ZnCl2 AQ plus H2OL. A sample of 3.50 gram of zinc oxide is added to 50 centimeter cube of 1.2 mole per dm cube hydrochloric acid. Show by calculation that the zinc oxide is in excess. We have the reaction equation. So what I will do, I'm going to convert the amount given into moles. Then we'll compare the moles. Either you can compare the moles of ZnO or 2HCl with the moles from reaction equation. So first of all, we need to convert these amount into mass, into moles. So for zinc oxide, the formula for zinc oxide is ZnO. Mr for zinc oxide will be, we have Zn. Where is Zn? Here is Zn. 65, it's Ar, oxygen, 16. So we'll add 65 plus 16. This will be the Mr of ZnO. So moles of ZnO will be 81. 3.5 grams divided by Mr, which is 81 here. 3.5 divided by 81. So the moles will be 0.0432. 0.0432 moles. What about HCl? We have 50 centimeter cube of HCl and the strength is 1.20 mole per dm cube. So for HCl, you can write 1000 centimeter cube contains 1.20 moles. Therefore, 50 centimeter cube contains X moles. Do the cross, what you will get? You will get X is equal to 1.20 into 50 by 1000. Point 0.06 moles. So you have moles of HCl, 0.06, and moles of ZnO is 0.0432. So according to reaction equation, ZnO reacts HCl 1 mole reacts 2 moles. Therefore, 0.0432 moles reacts with X moles. Do the cross. So X is equal to 2 multiplied by 0.0432 divided by 1. 2 multiplied by 0.0432. 0.0864. 0.0864 moles of HCl needed. And in the question, they gave us 0.06 moles. So, hence it's proved. Hence, proved that ZNO is in excess because HCl is the limiting reactant. Number 2, the formula for a calcium ion is Ca2 plus. Deduce the formula for calcium phosphide. We have Ca, phosphide means P. Remember, don't confuse this phosphide with PO4 or PO3. PO4 is phosphate and PO3 is phosphite. PHITE. What about the position of phosphorus in the periodic table? Here it is. It's in group 5, which means it has -3 as its valency. So I will write -3 for P. Calcium is given +2. Ignore the charges 2 and 3. These subscripts will be exchanged. So in the end, we will get what? Ca3P2. This will be the final formula. Question number 3, calculate the percentage by mass of phosphorus in calcium phosphate. Give your answer to 2 significant figures. Calcium phosphate. First of all, you should know the formula for calcium phosphate. Calcium phosphate is the formula Ca. Formula for phosphate is PO4. Calcium is in group 2. It must carry +2 charge. Phosphate carrying -3 charge. So ignoring their charges, subscripts will be exchanged. What we will get? We will get Ca3PO4 whole twice. Now we need to find the MR of these. We have 3 atoms of calcium. So 3 multiplied by calcium is in group 2. AR is 40. Phosphorus. Group 5, AR is 31. Oxygen. Group 6, AR is 16. 40, 31, 16. 40, 31, 16. For your convenience, I am writing it here, so that you don't need to look at the periodic table again. So 3 multiplied by 40 for calcium plus how many phosphorus? 2 phosphorus is there because 2 is outside the bracket. It means 2 phosphorus. So 2 multiplied by 31 plus 2 fours are 8. This is for oxygen. 8 will be multiplied by 16. 3 multiplied by 40, we'll get 120. 3 fours are 12. Plus 2 multiplied by 31. 2 threes are 6. 2 ones are 2. 62. Plus 8 multiplied by 16. 128. Adding up these, what we will get? 120 plus 62 plus 128. 310. 310 is the MR of Ca3PO4 whole twice. Now they are asking calculate the percentage by mass of phosphorus. We have 2 atoms of phosphorus, which means 2 will be multiplied by 31. So you will get 62. 62 will be multiplied by 100 and divide this by 310, which is the MR here. So 62 multiplied by 100 divided by 310, 20%. This will be the final answer for phosphorus. Question number 4. Oxides of nitrogen such as nitrogen monoxide, NO, are atmospheric pollutants. The exhaust gas from a car engine contains 0.002% by volume of nitrogen monoxide. Calculate the number of molecules of nitrogen monoxide in 960 dm cube of exhaust gas at room temperature and pressure. 1 mole of any gas or cube contains 6.02 into 10 to the power 23 molecules. They want us to calculate the number of molecules of nitrogen monoxide. So first of all, I need to calculate the volume of nitrogen monoxide in exhaust gas. The volume of exhaust gas is 960 dm cube and 0.002% is nitrogen monoxide. So we will find the point. So I will write percent of NO in exhaust gas is equal to 0.002 multiplied by 960 divided by 100. Point 00 multiplied by 960 002 multiplied by 960 divided by 100. 0.0192 dm cube. Now I need to calculate the volume of NO. Volume of NO, we know that 24 dm cube is present in 1 mole. Therefore, 0.0192 dm cube is present in X mole. Do the cross and we will get what? X is equal to 0.0192 divided by 24. 0.0192 divided by 24. This will be the moles of NO, 0.00008. Now, in order to calculate the number of particles or molecules of NO, we need to multiply these moles by the number of particles, which is 6.02 into 10 raised to the power 23. Point multiply by 6.02. 0.0048. 0.0048 into 10 raised to the power 23, or you can write 4.8 into 10 raised to the power 20. So 4.8 into 10 raised to the power 20. This will be the final answer for this question. Question number 5. The equation for the decomposition of aqueous hydrogen peroxide H2O2 AQ is shown. 2H2O to AQ gives 2H2OL plus O2 gas. 50 centimeter cube of a 0.2 mole per dm cube solution of H2 to AQ is used. Calculate the mass of O2 that forms. Use the following steps. Calculate the number of moles of H2O2 used. So first of all, we'll calculate the number of moles of H2O2. We'll use this information. Remember, 1 dm cube is equal to 1000 centimeter cube. So I will write 1000 centimeter cube contains 0.2 moles. Therefore, 50 centimeter cube contains X moles. Do the cross, you will get what? X is equal to 0.2 multiplied by 50 and divided by 1000. 0.2 multiplied by 50 divided by 0.01. 0.01. Next part, determine the number of moles of O2 produced. Look at the relation from reaction. From reaction, we have H2O2 giving O2. 2 moles give 1 mole O2. Therefore, 0.01 mole give X mole O2. So X becomes equal to 0.01 divided by 2. Point 0.005. Moles of O2 produced. In the next part, they are asking calculate the mass of O2 produced. For this, you need to know the MR of O2. 2 atoms of oxygen. So 2 multiplied by here is oxygen. 16, it's AR. 2 multiplied by 16 means 32. Simply multiply 0.005 into 32. 0.16 grams of O2. Moving to next question. Question number 6. In a titration, 25 centimeter cube of 0.08 mole per dm cube aqueous potassium hydroxide, KOH aqueous, is neutralized by 20 centimeter cube of dilute sulfuric acid, H2SO4 AQ. The reaction equation 2KOH plus H2SO4 AQ gives K2SO4 AQ plus 2H2O liquid. Calculate the concentration of H2SO4 in gram per decimeter cube using the following steps. First of all, they want us to calculate the number of moles of KOH used. So we have this information. This information is enough. As you all know, 1 dm cube means 1000 centimeter cube. So I will write 1000 centimeter cube contains how many moles? 0.08 moles of KOH. Therefore, 25 centimeter cube contains X moles. So do the cross. What you will get? You will get X is equal to 0.08 multiplied by 25 and divided by 1000. 0.08 multiplied by 25 divided by 1000. 0.002. 0.002 moles. Next part, determine the number of moles of H2SO4 which react with the KOH. We have the reaction. According to reaction, KOH, H2SO4. 2 moles react 1 mole H2SO4. Therefore, 0.002 moles react with X mole of H2SO4, or you can write X is equal to 0.002 divided by 2. So the answer must be 0.001 moles for H2SO4. Now calculate the concentration of H2SO4 in mole per dm. This is a mole for H2SO4 which has reacted, and the volume consumed here is 20 centimeter cube. So what you will write? 20 centimeter cube contains 0.001 mole H2SO4. Therefore, 1000 centimeter cube contains X moles. Do the cross, we get X is equal to 0.001 multiplied by 1000 and divided by 20. 0.001 multiplied by divided by 20. 0.05. In the next part, they are saying calculate the concentration of H2SO4 in gram per dm cube. We have the moles, that is 0.05 moles. I need MR of H2SO4. MR H2SO4. We have 2 atoms of hydrogen. So 2 multiplied by AR of hydrogen is 1. S, where is S? Here S, 32. Oxygen, 16. So 2 multiplied by 1 plus 32 plus 4 multiplied by 16. So we will get 98. So in order to get the mass in gram per decimeter cube, simply multiply the moles by 98. Moles into 98 or 0.05 into 98 into 98. 4.9 gram per decimeter cube. This will be the final answer. Moving to next question. The equation for the reaction is shown. ZnS plus H2SO4 AQ gives ZnSO4 AQ plus H2G. 25 centimeter cube of 2 mole per dm cube H2SO4 AQ is added to excess zinc. Calculate the volume of H2 formed at room temperature and pressure RTP. The volume of 1 mole of any gas is 24 dm cube at RTP. Use the following steps. Calculate the number of moles of H2SO4 used. So we'll start with the moles of H2SO4. The information is enough. We'll use this information. As I have already mentioned, 1 dm cube means 1000 centimeter cube. So you will write 1000 centimeter cube contains 2 moles. Therefore, 25 centimeter cube contains X moles. Do the cross. So X becomes equal to 2 multiplied by 25 divided by 1000. 2 multiplied by 25 divided by 1000. 0.05 moles. 0.05 moles of, these are the moles of H2SO4. Now deduce the number of moles of H2 produced from reaction. H2SO4, H2. The relation is very simple. 1 mole gives 1 mole of H2. Therefore, 0.05 moles give X mole. So you'll definitely get 0.05 moles of H2. Calculate the volume of H2 formed at RTP. At RTP, 1 mole of gas occupies 24 dm cube. Therefore, 0.05 mole of gas occupies X dm cube. Do the cross. X is equal to 24 multiplied by 0.05. 0.05 multiplied by 24. The answer will be 1.2 dm3. Last question, balance the symbol equation. Here's the reaction equation. You need to balance it. So for this, you can make a column for reactants and products. Reactants, products. We have N on the reactant side, oxygen on the reactant side, hydrogen on the reactant side, and all these three are on the product side. But count the number of atoms on each side. On the reactant side, we have 1, and product side is also 1. What about oxygen? 1 plus 2 plus 1 is 4 here. On the product side, it is 3. What about hydrogen? Hydrogen, it's 2 on the reactant side. On the product side, it's 1. So we need to balance both oxygen and hydrogen. So let's start balancing oxygen. On the product side, we can't get 4. What if I will place 2 before HNO3? 2 before HNO3. We have NO plus O2 plus H2O gives 2HNO3. Now let's count the number of atoms, each atoms on the product side. We have 2 hydrogen atoms. What about oxygen? 2, 3 is 6. We have 6 oxygen. Nitrogen becomes 2. Now can we balance it? Okay. If I will place 2 before NO on the reactant side, 2 before NO, then nitrogen becomes 2. What about oxygen? 2 plus 2, 4. 4 plus 1, 5. So what if I will place 2 before O2? 2 plus 2 multiplied by 2 is 4. 2 plus 4, 6. 6 plus 1, 7. So this is not working. This is not working. Oxygen remain unbalanced. Okay, let's increase the number for HNO3. Let's make it 3. What if I'll write 3 before HNO3? But if I will write 3 before HNO3, we can't balance hydrogen. We can balance nitrogen, we can't balance hydrogen because you can't place 2 before H2 in order to balance the hydrogen on the reactant side. So instead of placing 3, let's directly place 4 before HNO3 and see the number of atoms, each atom on the product side. Nitrogen becomes 4, hydrogen, it becomes 4, oxygen 4, 3 is 12. Now on the reactant side, what if I will place 4 before NO? Nitrogen become balanced. What about in order to balance hydrogen, I have to place 2 before H2O. Hydrogen is also balanced. What about oxygen now? 4 plus 2 plus 2, which means it's 8. What if I will place 3 before O2? 3 to the 6, 6 plus 4, here 6, 4 and 2, which becomes equal to 12. Now this equation is balanced. So I will write 4 here, 3 here, 2 here, and 4 here. This equation is now balanced. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.